high school kids saying?
Hey, high schoolers, we'll dismiss you now. Thank you for that reminder.
Well, I see what you mean. I hope the church doesn't tilt like that island that representative said. If we get too many Marines there, won't the island sink? That's our representative. What a beautiful Mother's Day, huh? Happy Mother's Day. To my way of thinking, nothing says Happy Mother's Day quite like a Sunday school lesson on dating. I didn't plan it that way, but that's the way it is. Last week we talked about the philosophy of science. Which glasses are you wearing? What is your frame of reference? What are your basic beliefs? I would like to posit these 5 things for you. God does exist. Real truth is knowable. Science verifies the creation, and Scripture is unique. Those are things that I think you and I both would attest to. From my perspective, nature reveals the Creator, and science verifies creation. So, just briefly, I have hundreds of optical illusions. Stare at the little crosshairs in the center of the picture. You're getting sleepy? I didn't get any checks last week. What happens? I've never done it in this large of a venue. Does there appear to be a green spot that appears if you're staring right at the... And doesn't the pink ones, don't the pink ones disappear? So you are actually seeing something that you're not seeing, that isn't there. Another optical illusion. That's a pretty cool one, I think. So, are you wearing the glasses of catastrophism? We believe that there was a catastrophe, Noah's Ark, a worldwide flood, and it accounts for most of geology. Or do you believe in uniformitarianism? The present is the key to the past. Things have gone along the same over millions of years. If you believe in catastrophism, you believe in a young earth. Uniformitarianism, you believe in an old earth. The definition of science, the cardinal rule for theists and non-theists alike, has been to limit the scientific explanations to natural causes. I would argue with that. I would consider myself to be a theist. And why would we take issue with that? What, Earl?
Because God can supersede natural causes with his supernatural ability.
Absolutely. The word supernatural. We would argue with this. We would not say that's the cardinal rule for theists and non-theists alike. As theists, we believe in miracles, the miraculous creation. So here's a pretty important scientist from the past, Johannes Kepler, thinking God's thoughts after him. Do you realize if you go back in the scientific progression over the years, many would hold the same position that you and I hold?
But that's not science.
Of course, the smartest person on The Simpsons would come up and say, that's not science. Everybody else on The Simpsons is stupid, except Lisa. Sir Isaac Newton, in probably the most revered scientific expose ever or written in Principia, persuade thinking men to believe in a deity.
But that's not science.
And of course, she comes up and says that too. So your presuppositions, your assumptions, your worldview, that determines how you think about the earth, about the universe, and also about what you believe about the afterlife too. So today, radiometric dating, the dating game. I haven't quite decided what I want to do in the next two after this. The geological column, genetics, chemical evolution, or the beauty of it all. If somebody says, I would really like to hear that, email me and you could change my mind, which hasn't been made up anyway. So the dating game. Do you remember? Was this the 60s? 60s, 70s? Was it the 70s? So Lori was on the dating game. She was the bachelorette. And I was one of the bachelors. There was heavy competition. And I was really nervous about the competition. But at the end of the episode, she chose me. Now, during our dating period, she really didn't open her mouth much. Those of you that know me know that I like to talk. I like to tell jokes. And so, things went along fine. And we decided to get married. And finally she did, oops, wrong way. Finally she did open her mouth. And I was already committed. So, you don't back up. Okay, she's got a tooth problem. That'll be all right. I didn't really think about it too much until the children came along. And, of course, we had some pretty good dental bills. Now, I need a volunteer for this demonstration. And this is going to be one that you're going to sit at your seat. But, I taught second grade this week, and I asked for volunteers. Every hand goes up. And then some of the kids, their hand goes up the entire time that I'm talking. 45 minutes, the hand up, you'd think their arms will get tired. But this is simple. You will? Thank you. I know, you're looking up here and you're going, okay, the instructions are in the little.
I have to read.
Could I have another volunteer? The instructions are inside there. If you or any of your IM force are caught or killed, the secretary will disavow any knowledge of your activities. What was that from? Mission Ridiculous, right? So I'll get back to you in about 10 minutes, 10 or 15 minutes. Yeah. No, this isn't a minute to win it or anything like that. So, introduction to dating methods. There are literally hundreds of dating methods that could be used to give an estimate of the Earth's age. Literally hundreds of them. The vast majority of them point to a much younger Earth than the 4.5 billion years claimed by secularists. I invite you to go to this webpage, and again, my email, dclarkchem, because I was a chemistry teacher, at AOL.com. I'll send you this link. One, the salinity of the ocean. If you do a calculation of how much salt is going into the ocean every year now, and do the calculations back, I think it comes up with about 20,000 years for the age of the Earth. If it was 4.5 billion, it would be too salty. Too salty. Importance of long ages, that's a topic I want to cover. What is radioactivity? Carbon-14 dating method, assumptions in all dating methods, and the rate project. There's a philosophical bias. Our ways of learning about the world are strongly influenced by social preconceptions and biased modes of thinking that each scientist must apply to any problem. the stereotype of a fully rational and objective scientific method with individual scientists as logical and interchangeable robots is self-serving mythology. I would agree with that. Scientists are not unbiased. They're not unprejudiced. And this was by Stephen Gould, a devout atheist. So that's why I quoted him. Many scientists believe that the universe is billions of years old. So pond scum turns into, well, you can say, don't say it. Don't say, turns into a person.
What difference at this point does it make?
They believe in from the goo through the zoo to you. Okay? That's what they believe. Many scientists believe that the universe is billions of years old. Young Earth creationists believe the universe to be about 6,000 to 10,000 years old. Earl asked me after the Sunday school last week, how old do you think the Earth is? I'm not sure that it was 9 a.m. 4004 BC. I'm not sure of that. But somewhere in the 6,000 to 10,000 year range. Clearly there's a contradiction for those of us that believe Genesis 1.
God saw that it was good. There was evening and there was morning, a fourth day.
God saw it was good. Verse 9, 12, 18, 20, 25, 31, hike. All of those verses say God said it was good.
Thus the heavens and the earth were completed, and all their hosts.
Completed. We believe the earth was completed, not set up so that it could evolve over millions of years.
By the seventh day, God completed his work which he had done, and he rested on the seventh day from all his work which he had done. Then God blessed the seventh day and sanctified it, because in it he rested from all his work which God had created and made.
And I'm quoting John MacArthur when he said, when does it kick in? When do you start believing the Bible? Do you just get rid of the first 2 chapters? The first 10 chapters? I think you have to use scissors on a lot of Scripture if you don't believe in a literal 6-day creation. Example, Exodus 20. Remember the Sabbath by keeping it holy. 6 days you shall labor and do all your work. For in 6 days the Lord made the heavens and the earth, the sea, and all that is in them, but he rested on the 7th day. Therefore the Lord blessed the Sabbath day and made it holy. Of course, we as Christians don't keep the Sabbath, but in our case, we don't go out and mow the yard on Sunday. And we wouldn't mow today anyway. And would you have to throw out Romans 5:19? For as through the one man's disobedience the many were made sinners, even so through the obedience of the one the many will be made righteous. Well, I think there are some people that believe in millions of years that say there actually is an Adam. I mean, this verse doesn't make any sense if there's not actually an Adam. But as I pointed out, have you not read that he who created them from the beginning made them male and female? From the beginning, not millions of years later, from the beginning. You've already seen this. The Big Bang, 14.5 million years ago. The Earth, about 4.5 billion years ago. First life, 3.5 billion years ago. Sponges, 1.5 billion years ago. SpongeBob and Bikini Bottom. Okay. Bob Marion, Homo sapiens. He who created them from the beginning. So, he created man here? That doesn't make any sense, does it? Well, Jesus didn't understand about the geological ages. The importance of long ages. Evolutionists generally feel secure even in the face of compelling creationist arguments today. And there are a number of them, and I've given you references. ICR.org, Answers in Genesis, 2 excellent sources because of their utter confidence in the geological time scale, that thing that I just put up. Dr. Baumgartner, with the discovery of radioactivity about 100 years ago, evolutionists deeply committed to the uniformitarian outlook believe they finally had proof of the immense antiquity of the Earth. Proof, we have proof.
Not so fast,
Not so fast. We have some questions we would like to ask, some scientific questions, not necessarily religious questions, but scientific questions. Without millions and millions of years, the theory of evolution absolutely crumbles. I tried to use a little bit of a Twitter lingo here. I have to learn you a little bit of chemistry. So I'm going to use the periodic table. Where do you guys keep the periodic table? What kind of a classroom is this? There's a guy at Frontier. I would say, you're not a real teacher if you don't have a periodic table. So I gave him one, a little paper one, and he put it on his wall and kept it there for years. So I'm going to have to teach you a little bit of chemistry. Sorry about that. There are 3 basic particles in an atom. What are they? What's that? Electron, yes. Proton and neutron. Those are the 3 basic particles. So I'm going to represent a proton with this. What's the charge on a proton? Positive. Okay? I'm going to represent a neutron like this. What's the charge on a neutron? No charge. So you could run into Wally World or Major this afternoon, grab a bunch of neutrons, run through the checkout. The waitress there, what do they call them? Cashier. When she says, okay, you got your neutrons here, no charge, go out the door. Doug's going to be my pa-dum-pump. Okay. And the electron with a charge of negative. Okay. Now, here's my periodic table. You know, chemists, if they don't have a periodic table, they're kind of lost. Kind of like the preacher, if he doesn't have the Bible, he's not really a preacher of God's word, is he? So let's zoom in here on helium, upper right on the chart. Does anybody know what family that's called? The rightmost family, group 8? It's called the noble gases. Very good, the noble gases. When I was in high school, we were taught they were the inert gases because they didn't react with anything else. Since that time, they've discovered under extreme conditions they can react. Oh, by the way, when I was in 8th grade, we had to memorize all the elements and symbols, all of them. Somebody says, big deal, Mr. Clark. When you were a kid, there were only 3 elements discovered. I can't think of a more worthless exercise, but I did what I was told to do, memorize them. So let's enlarge that. Helium, the numbers mean this: 2 protons, 2 electrons, 2 neutrons. By the way, this is the atomic theory. The atomic theory. I never demanded that the students say, okay, it's fact. Now, everything that we've studied, I could show them dozens of demonstrations or experiments through the year that indicated that this is true. But if they want to come up with something else, something they think is better, I would accept it. They never did, obviously. So 2 protons, 2 electrons, 2 neutrons. Here's where they are located. All right, protons and neutrons in the nucleus, the 2 electrons orbiting. Helium is a very stable isotope. Isotope. We're in nuclear chemistry, so I will call it a nuclide, because that's the language that we use when we're studying nuclear chemistry. All right. How can we calculate how long the hourglass has been running? Now's the time when we're going to have a look at what, I didn't know who was going to do this. Peggy, has been up to. Let's watch what she's doing. Somebody have a watch? We don't have watches anymore. We have cell phones. Time this for us, will you? Go ahead and show them what you're doing. Hold it up so that she can sit. 7, 8, 9, 30, 1, 2. Oh, you're counting. They have these things called watches. They have these cell phones. Okay, let's not waste much time. Every 30 seconds. Now, this is science. Would you open up the box and count how many? She's dropping paper clips in this box. Okay, it's kind of the opposite of radioactivity. Radioactivity is decreasing the nucleus. We're adding something here. You go ahead and open the box and count the number of paper clips that are in there. What we want to do is we want to calculate how long she's been dropping paper clips into the box, right? It's a legitimate scientific thing that we could do. All right? We'll come back when she's done timing, when she's done counting. So, how can we calculate how long the hourglass has been running? You figure out how much sand, right? How much sand's in the bottom, how much sand is in the top, figure out the rate. There's a whole mathematical discipline called, it's not calculus, it's one step beyond calculus, differential equations, dx, dy, and that kind of stuff. Count all of them. How are we doing there? 22, 24. Welcome back. What assumptions have we made? We made this, the amount of starting material. Constant flow of sand. Nothing has been added. Nothing has been removed. Those are things that you'd have to assume in order to be able to calculate how long that hourglass has been running. How many? 60. So, 60, she just did 60. So if she's dropping them every 30 seconds, that's the rate. She's been there 30 minutes. She's been there 30 minutes dropping the paper clips in there, right? Why not? Because I had some in there to begin with, didn't I? Yeah, and then when you said just the ones I've dropped in there, yeah, just count the ones you've dropped in there. How are you going to tell? Oh, okay. All right. Well, we just used science, but we came up with the wrong answer because, oh, by the way, that little cloth in there has been soaked in the Wuhan Red Death virus. So don't worry about that. You're over that. Okay, what is radioactivity? How do they use radioactivity to determine how old things are? Radioactivity is a general term for the breakdown of unstable nuclei. Many isotopes or nuclides are stable. They're happy the way they are. There are some nuclides or isotopes that have varying numbers of neutrons and they're not stable. And they spontaneously decay to produce alpha, beta, and gamma. I always like to ask this question in class. This, to me, was a fair question. What's the alpha and omega? And if I had a class of 24 students, how many students do you think would get it right? 2 or 3. And you know what I knew about those 2 or 3 students? They knew parts of the Bible, didn't they? The Alpha and Omega. What is that? The first and last letters of the Greek alphabet. Alpha, beta, alpha, omega, right? Alpha and beta particles and gamma rays. Somebody goes, why did they use Greek? Why didn't they use English? Well, How many letters are there in our alphabet? 26. You run out of letters pretty soon, don't you? How many things does V stand for? Velocity, volume.
The evidence indicates that Iraq is reconstituting its nuclear weapons program.
Nuclear. It's pronounced nuclear.
Saddam Hussein has held numerous meetings with Iraqi nuclear scientists.
It's pronounced nuclear.
A group he calls his nuclear mujahideen, his nuclear holy warriors.
It's pronounced nuclear.
No, it's not pronounced nuclear. You're president of the United States. You don't have science advisors that would say, you know, you look kind of dumb when you say nuclear. It's nuclear. There's not that extra syllable in there. So, a radioactive atom gives off energy and a particle. And we don't have any control over that. However,
Nuclear. It's pronounced nuclear.
no, it's not. If I had a Geiger counter, if I had one, okay, and it's connected to our, okay, got it? All right, let me turn this on. Now that's background radiation. We did this so that the whole group here could hear that. You are being struck with radiation right. Oh, that was close. You're being struck with radiation right now. You have no control over it. It just happens. Okay? Let me turn it off. It's obnoxious. All right. If I had a Geiger counter, by the way, a Geiger counter does not distinguish between alpha, beta, and gamma. An event happens, it goes into the tube, it makes a click, or a count, or a beep, and we can record it. An alpha ray is a helium nucleus it doesn't have the electrons. It's just like a helium atom, but it doesn't have the electrons. But it came from the nucleus. A beta, actually, it should say particle, is simply an electron. A neutron in the nucleus, not stable, it ejects an electron and the neutron becomes a proton. Gamma is a wave. All right? Now, see if I can go a little further here. This is helium, 2 protons, 2 neutrons, 2 electrons. 2 protons, 2 neutrons, 2 electrons. Helium atom, alpha particle. What's the difference? The 2 electrons are missing. All right? By the way, when an alpha particle comes out of a nucleus, it can pick up 2 electrons and become a helium atom. Okay, there's the alpha particle. If I had a Geiger counter and an alpha source, I'm going to skip ahead because I'm going to go up here to the table and demonstrate something in a moment. Polonium-210 is a radioactive material, a radioactive atom. And one thing I want you to notice here, 138 days. Okay? So let me get the alpha. If I had an alpha source, if I had one, let me get that out. Okay, and we need the Geiger counter on again. Okay, background radiation. Here's the interesting thing about alpha source. Don't worry about it. Background radiation, there's nothing you can do about it. Piece of paper. Our bulletin today. Stop. It's background radiation, stopped almost completely by a sheet of paper. I know that's disconcerting when you... Let me go ahead and, while I'm here, get out the beta. The beta. Background radiation. Let's see what happens with that. Let's see if a sheet of paper stops it. It doesn't stop it. Let's take a piece of aluminum foil. Aluminum foil. Pretty close to stops it. Now let's go with the gamma. The gamma radioactive source. By the way, for over 30 years, I used the Geiger counter and radioactive sources because I was part of the Purdue ChemVan project. They delivered hundreds of thousands of dollars worth of equipment to our schools, and I was in that project, and it was really cool to be able to do that. Let's see this one. I know. Let's see if paper stops that. You want to move? You've been irradiated quite a bit. Let's see if the aluminum foil stops it. Okay. Again, background radiation. Here's a piece of lead. Some of you have been asking me about, my rehab on my shoulder, and it's going pretty well. Well, look at that. I could only go here a month ago. So, anyway. Yeah, that's lead. I know. Corny. But you know what? The kids love it. So, put the lead up there. Almost completely stops it. So, what, you guys going to run this afternoon and get some lead underwear? Protect yourself? Oh, wait, you can't go to Sears. They no longer exist. Okay, we're going to go on with these radioactive sources. There's the strontium, has a 28-year half-life. More about half-life in a moment. And the cobalt-60. That's hard to see, 5.3 years. All right, now let me explain half-life. Before I explain half-life, I want my beautiful assistant to come up here. And let's just see, somebody earlier said, I think both Joe and Peggy said, did you bring that? Yeah, you're going to have to bring that. Let me turn this back on. And let's see if... go ahead and turn it on. All right, let's see if the cup is radioactive. All right, let's see if the matches are radioactive. Let's see if Laurie is radioactive. Let's see if I'm Let's see if Phyllis is radioactive. All right. She's radioactive. Let's see if Bob is radioactive. His jokes are. No, this isn't plugged into anything. I was simulating, and by the way, if I had a Geiger counter and radioactive sources instead of candy, you would hear the same thing that I just showed you. And believe me, after 30 years of doing this, I know. I looked over there one time because she had the sound wrong. Beta is not blocked by, beta is blocked by aluminum foil. I think you did it right, and I had it backwards. So this is a little prank, but it does illustrate. We're done with that. Now back to some real science. But I simulated the way it would be if a Geiger counter is somewhere between $300 and $400. The nuclear sources are about $80. I'm going, I don't know, for a Sunday school lesson? I didn't think so. So, carbon-12. Carbon-12 is a stable nucleus. It is not radioactive. It doesn't eject anything from the nucleus. You have a lot of carbon-12 in your body. Most of your carbon-12, or most of the carbon in your body is carbon-12. Carbon-14, however, has 2 more neutrons. It is there's our representation of carbon-12, stable nuclide. 6 protons, 6 neutrons, 6 electrons. Add 2 more neutrons to it, it becomes carbon-14. It is radioactive. It would give beeps if I had a Geiger counter. Here's the best I can do for radioactivity. 138 days, polonium turns into lead, and it has a half-life of 138 days. After 138 days, if you had a sample that was giving off, say, 1,000 disintegrations per minute, 138 days later, it would give off half of that. Another 138 days, half of that is gone, and so on down the line. Here's how polonium-210 decays. Actually, the kids were very scared of balancing nuclear equations. It's quite simple. The numbers, which we call superscripts there, have to equal each other, and the subscripts have to equal each other. So 210 has to equal 4 plus 206. 84 has to equal 2 plus 82. If we look at the periodic table, what has an atomic number of 82? Lead. Polonium is changing into lead. And it's doing it at the rate of every half of it every 138 days. All right? So, there it is again. 138 days. Here's what we think goes on in a nucleus. It's not stable. Out comes an alpha particle. It makes a click on the Geiger counter. And now the nucleus is stable. There's another alpha decay. Uranium-238 is an alpha decay. Half-life is the time it takes for 1/2 of the atoms of a radioactive sample to decay. Strontium-90 is another radioactive sample. I'm not going to be able to get to that. Now, we actually would make barium-137M in the laboratory. My Chem 2 class did that every year. And this is the equation, nuclear equation for that. You can see no numbers changed. Barium just becomes less radioactive over time. So this is actual data that the students got. They would make the substance, go back to their desk. They had a nuclear scaler. They would count the number of clicks after 1 minute, 3 minutes, 5, 7, 9, and 11. And then we would graph it. That is typical of radioactive decay. And then they would calculate the half-life. That's not that difficult, actually. Pick two numbers. Pick one number. 1,000, go down, figure out the radioactivity of it at 5 minutes. Then half of that, go out, figure out what that was, where it hit the graph, come down. I think the half-life was about 4 minutes. They would start with rubber gloves on. At the end of the period, they could drink it if they wanted to. It wasn't radioactive at all. Now, how does carbon-14 work?
If it has a half-life, does it ever actually lose all of its radioactivity?
Yes. That's one of the problems with carbon-14. Yep. Now, we could debate about that, you know. For example, if I gave you a candy bar and said, eat half of it, okay, how much do you have now? 1/2. Okay, eat half of what's left. How much do you have now? 1/4. Eat half of that. How much do you have? 1/8. Eat half of that. What do you have left? 1/16. Eat half of that. 1/32. And so on, right? You'd never run out of candy bar if you kept eating half of what was left. But essentially, what happens is you get to a point where you cannot distinguish the radioactivity from the background radiation. That's what you get to. So carbon-14 is a symbol. Carbon-14 has a half-life of 5,700 years. Carbon-14. Are you a living organism? Do you have carbon-14 in your body? You are radioactive. Every one of you are radioactive. How far can I get? Yeah, but we've dealt with that our whole lives, haven't we? Well, not the last year and a half. Carbon-14 is believed to be able to give absolute dates to fossils. But how did you get carbon-14 in your body? Here's how. Here's the pathway. Cosmic rays strike the atmosphere. What's primarily in our atmosphere? Nitrogen. N2 strikes nitrogen. When it does that, it turns the nitrogen into carbon-14. Carbon-14 is radioactive. Do you breathe in carbon in the atmosphere? No. It combines with oxygen to form CO2. Do you breathe in CO2? Yes, you do. Does your body use it? No. You breathe in a certain amount, you breathe out more. Your body doesn't use it. What uses carbon dioxide? Plants. So, here's something that you could say. If the kids were here, I'd tell them this. When mom gives the corn or beans or broccoli or cauliflower or celery or carrots, you go, no thanks, Mom, it's radioactive. No thanks. So what do the kids do at lunch? They open up the bag of corn chips and they go, oh wait, corn, that's radioactive. Throw away the corn chips and eat the bag. You say, well, this is a very good reason for me to become a meat eater. There's only one problem with that. Animals eat plants. And you eat plants and you eat animals, don't you? So you're kind of stuck here. Oh, just give me the non-radioactive food. Doesn't exist. Does not exist. So let's take a look at two animals. This is Leon Siegler drew this for me back in 1975, I think, 75, 76. So he gets hit. This is a Dedibertosaurus. And he named it too. So what happens after 1,000 years? It begins to decay. It begins to fall apart, deteriorate. Another 1,000 years pass. Decays even further. During that time period, what's happened to the carbon-14? It's going down because he's not replenishing his food. Okay, you want to decrease your carbon-14? 2 ways to do it. Die, and the others related to it, stop eating. That's the only way you can reduce your carbon-14. Okay, here's another one. Geekus Maximus. I can't take credit for that. Leon Siegler, back in 70 something. Cubs in 2003. You can tell this is a little bit dated. How many remember this? You may not know the explanation, though. Steve Bartman, his life was threatened. Just a quick little, oops. Now I have his life was threatened because he tried to catch a foul ball. I actually have a stop action on this. What actually happened. So it wasn't Steve Bartman's fault. Geekus Maximus, 1,000 years pass. Cubs in 3. You know, this doesn't make any sense because the Cubs have won the World Series since that time, haven't they? I tried to think about how I could update that. Another 1,000 years pass. Cubs in 4003. Cubs in 5003. Oh, just forget it. Can't do that anymore. So if we looked at the two animals, compare them, Geekus Maximus continues to consume food and his carbon-14 stays relatively the same. However, the Dedibertosaurus, his carbon-14 goes down. So, all you have to do is look at the graph. Now, this is a different radioactive substance, but you can tell how old something is by how radioactive it is. Figure out the radioactivity, figure out, in the case of carbon-14, when it died, when it stopped taking things in. Now the radioactive decay, they all look the same. This is a very interesting video. I don't have time to talk about it though. But he goes through all these calculations and all these people comment on what he did in the video. And I have 3 points I would make about what he did. Number one, circle your answer. -1, didn't circle your answer. And this right here. How do you know what you started with? You have to make some assumptions what you start with in order to come up with an absolute age for something. If you don't know, and so I marked that up there. But all the comments, oh, this is wonderful, blah, blah, blah. I didn't have time. I was going to say, well, how did you know what it started with? How did you know how much the Pharaoh had? 3,000 years ago? 2,500 years ago? How do you know how much carbon-14 he had? Were the Egyptians doing carbon-14 dating? No, we just found about radioactivity about 100 years ago. Okay, the guy who developed this, Libby, said this. The first shock that Dr. Arnold and I had was when our advisors informed us that history only extended back 5,000 years. We had thought initially we would be able to get samples all along the curve back to 30,000 years, put the points in, and we're done. Not the case. We learned rather abruptly that these ancient ages are not known accurately. There's the reference there. Now, I'm going to talk about the assumptions in carbon-14. The decay rate of carbon-14 has been constant over the entire time period of the fossil. This has to be true in order to give it absolute ages. Are you sure? No decay products have been added or removed. The ratio of carbon-14 to carbon-12 has been constant over the entire time period of the fossil. Here's from New Zealand, carbon-14 in the atmosphere, and you can see there was a spike back here, a spike in that. It's not constant. The Earth's atmosphere has never changed. What do you say about that? Before the flood and after the flood. Before the flood, it hadn't rained, right? The Earth's magnetic field has never changed. I got to figure out how far advanced to go here to draw this to a conclusion. A fundamental assumption of nuclear physics, the predictable decay rates of radioactive materials, has been open to question. Predictable decay rates. I don't argue too much with that, but what happened during the Great Flood with the rain like we're having today? What happened there? Wilder Smith, you can change some of the half-lives of some of these compounds to whatever you want. Let me move ahead here. Otherwise, I'm just going to go right here. 133. Maybe. It turns out that every one of these assumptions they make may or may not be true. Every one of them. So what would you say about carbon-14? It's science, but it may not be true. I like this. Every dating method, potassium, argon, uranium, lead, every one of them, they have to have constant decay rates. That's an assumption. No decay products have been added or removed. The original amount of the parent nuclide and daughter nuclide has to be assumed. Then there are all kinds of anomalies, things that don't make any sense. Let me go here. Stephen Austin sent in a sample to one of these places and said, "Tell us how old this is." And they said, "Where did you get it?" He says, "I'm not telling you." They came back with let's see if I have it here. They came back with 0.2, yeah, it's on the next page. The potassium argon, they came back with 0.25 million years for the age of that sample. It's 1986. So there's all kinds of anomalies. You can look at those sites. Again, you look at a candle and you go, how long has it been burning? Figure out the rate of the burning. Figure out how do you know when it started? How do you know they didn't come along and blow it out? Did it burn all that time? The Rate Research Group, I have this book. It's a tough read. Radioisotopes and the Age of the Earth, the RATE project. But there are several questions that they ask. And it's a difficult read. But I would say this, I would summarize by saying radioactivity is thus shown experimentally not to be, as described by Millikan, an unalterable property of the atom. Half-lives are not constant. This procedure is not perfect. It's got errors. It's got assumptions. Let me jump to here. I noticed this email came in this week from creation.com. Historical Adam, free. You could get that free. I'm going to watch it. Next week, the geological column, maybe. I'm not sure exactly what I'm going to do next week. But happy Mother's Day. Yes, Earl?
Just a question maybe for next week or something. Among evolutionists, is there contradiction among themselves as to what the Big Bang means?
You could talk to 5 different evolutionists. They would give you 5 different answers. So,
I got one now. Right here. I don't know if this is correct or not, but I have heard that the rate of decay of a sample could be skewed if it had been submerged in water.
if leaching occurs, absolutely. But I don't know that many radioactive samples that are water soluble. But yeah, I'm not familiar with that.
Again, I want to thank Mr. Clark for this presentation. I think this one was a little bit tougher maybe to follow than some of the past, but if anything, it expands our knowledge and our appreciation for all that goes into what quote-unquote scientists use for their dating, and what, again, back to the basic premise, what you believe has to be with what you start with. So just another challenge to us this morning.